In the pre-lab video, I did the experiment myself and I showed you how to do the calculations. In this segment, I'm going to do the experiment for you. I'm going to make the measurements and you're going to do the calculations. And they're very similar to the ones I did for you. I'm going to use this Vernier pH pen. It is stored in a solution that keeps the glass bulb moist. They're quite amazing devices. They can measure very sensitive amounts of ions. Okay, so the first thing I'm going to do is fill a well with 0.1 molar acetic acid. But the problem is the 0.1 molar is still on campus. I only have 1 molar. So what should I do? Oh, I could dilute it. So what I'm going to do is take a graduated cylinder and I'm going to add 1 milliliter of 1.0 molar, and I'm going to dilute it with 9 milliliters of deionized water to a new volume of 10 milliliters. And that is like cutting it to 0.1 molar. And I'm going to mix it well. And then I'm going to pour some in this spot plate and measure its pH. Okay, so the pH is 3.20. Now I'm going to wash off the tip. And I'm going to take some 1 molar acetic acid. I'm going to put it in another well, and then we're going to measure the pH of that solution. So do you think the pH is going to be higher or lower? This time the pH of 1.0 molar acetic acid is 2.61. In the third well, we're going to add 4 milliliters of 1.0 molar acetic acid. I'm sorry, 0.10 molar acetic acid and 1 milliliter of 0.10 molar sodium acetate. So I'm going to add 4 of these milliliters that I made previously. And 1 milliliter of 0.10 molar sodium acetate. So the total volume is going to be 5 milliliters. Now I'm going to pour the rest of my acid in here because I want to mix well, and we're going to measure its pH. So by adding the common ion, the acetate, in the form of sodium acetate, do you think the pH should go up? Should it go down? Which way would the equilibrium shift of our equation? Would it shift to the left or would it shift to the right? Well, in this case, the pH is 4.27. Okay, now we're going to add 2 milliliters of the acid and 3 milliliters of the sodium acetate. So I need to make more of my acid. So again, I have 1.0 molar, and what I'm going to do is dilute it again. So that it becomes 0.1 molar. I'm adding 9 milliliters of water to 1 milliliter of the acid. It makes a total of 10. Get that meniscus. Let's rinse out our graduated cylinder so we can mix. Okay, so again, I'm going to add 2 milliliters of the acid to 1 milliliter, 3 milliliters of my salt, the sodium acetate, for a total of 5. So you're going to do the M1V1 equals M2V2 calculations. I'm going to save my 0.1 molar acid in the dropper bottle for later. I'm going to rinse out my graduated cylinder and mix away. Okay, and this is in the 4th well. All right, now let's measure the pH. Again, what would your prediction be? Would the pH go up? So now we've added 3 mils of the sodium acetate. So does that shift the equilibrium to the left or to the right? And we get a pH of 5.06. Okay, the last thing I'm going to do is take 1 milliliter of this solution that I just made. I want 1 milliliter of it, and I'm going to add to it 4 milliliters of water. So let's see if I can do it in here. 1 milliliter of that mixture. And then I'm going to add 4 milliliters. So M1 is going to be the concentration that you came up with for M2. Okay. Pour that out. This will be our final mixture. Hey, I'm glad I didn't knock anything over. Going to mix it back and forth. Then you're going to do all the calculations. I've provided examples for you in the pre-lab. Okay, we get a pH of 5.04. So now you can write down, hopefully you've collected all that data so you don't have to watch this again, but you can do the calculations and complete the lab on your own. Thank you.